Venus apart. This is a world that has been tortured by fire. Over 1,600 giant volcanoes puncture its surface. It's possible some are still active.
If we could just hover like this over Venus, it would probably look a lot like this.
Mark Bullock enjoys spending time on Venus, at least the version he finds here on Earth.
Hawaii has some of the most spectacular shield volcanoes that are very similar to the volcanoes that we see on Venus.
The huge, gently sloped volcanoes of Hawaii may be impressive. On Venus, there are at least 150, ranging from this size to 10 times larger. But the observant visitor may notice that Venus is missing something.
The whole impact crater situation on Venus is really very puzzling.
With the Magellan images, we see really a small number of impact craters, and it's such a small number, it's about 1,000. Because we know the rate at which impactors come in, we can actually date the surface to somewhere between 300 million and 1 billion years old.
Sometime in the recent geological past, it seems the entire surface of Venus was remodeled. And suddenly,
the surface geology of Venus is different than the Earth, basically because of lack of water. Water is not lubricating that crust, so you don't get plate tectonics. Instead, what seems to happen is that forces inside the planet are trying to move things around, but it can't. It's locked. And then an very massive, globally explosive episodes that happen about every 500 million to 1 billion years. So you would not want to be on Venus when that happens, because once something gives way, the whole planet might just basically explode in a sense and turn itself over in a very short amount of time in geological terms.
Oh man, look at this. We can see a river of lava beneath the surface. Imagine that this lava is on Venus. Probably something very much like this occurs either today or in the recent past.
no one can say for sure if we'll ever see an eruption like this on Venus. No one has ever been able to get this close.
One of the really exciting and high level of scientific interest is whether Venus is geologically active today, because there are reasons to think that the clouds on Venus only exist because there is ongoing geologic activity. So this is one of the big secrets of Venus and something that we want to find out.
In recent years, finding the source of Venus's thick atmosphere has become surprisingly relevant for all of us down here on Earth.
500,000 tons of sulfur dioxide spewed into the atmosphere every year.
The whole greenhouse effect was not really recognized as a significant effect to influence planetary climates until we went to Venus and found that instead of being at 90 degrees Fahrenheit, it was 900 degrees Fahrenheit. And we said, whoa, what's wrong with this? Let's learn about this. And it taught us about the greenhouse effect.
Ever wondered how alien a planet could be? How bad a climate can get? Try the planet next door. The best way to experience Venus is to hitch an imaginary ride on a Soviet Venera probe.
Well, it would be a wild ride.
The clouds start about 40 miles up, some 5 times higher than the Earth's.
What were those clouds made out of? They're not made out of water. They're made out of a completely different substance. They're made out of sulfuric acid. Everywhere you go, the atmosphere is going to try to eat you away.
As you get deeper, things heat up. The thickening atmosphere allows the sun's heat in, but not out. It's also getting dense. So dense, your probe drops like a coin in water.
as we descended, the surface would gradually sort of appear to us as if we were approaching the bottom of the ocean.
Congratulations! You've arrived on the hottest surface in the solar system. Here, the official temperature is 870 degrees Fahrenheit. Day or night, equator or pole, the searing heat never varies more than a few degrees. And it's why we have so few snapshots from the Venusian surface.
So why is it so hard to bring scientific instruments to the surface of Venus? What about an ordinary camera? There's plenty of light there. Why not just send a camera and take pictures? I've got my NASA-issued spacesuit here, my special Venus suit, and let's take this camera and send it to Venus and see what happens.
Primarily, you don't want to melt. It's such a hot environment that all the electronics, all the power, all the communications have to be very rugged.
Oh, that's cool, though.
Anything mechanical, anything electronic is just an enormous challenge to have it function on the surface.
And it's not just the heat that you have to bear. All that sky above is really heavy, pressing in at around 90 times the pressure on Earth.
When I was a graduate student, we used to get in conversations about what would get you first, the temperature or the pressure. It would be pretty simultaneous, I think.
To descend to the surface of Venus is the same as diving over half a mile underwater.
It's an enormous pressure, enormous crushing pressure. How do you make things that withstand? How do things turn and move under those huge outside pressures? Well, that's what the armor of technology is all about. The exosuit, using composite fiber and strong aluminum alloys and stainless and titanium and all these things, it looks like something out of Transformers or out of a comic book. That's the same kind of suit that you'd need on the surface of Venus.
You'd never guess the dangers on the ground from orbit. Except maybe for this, massive, double-barreled storms hovering above the poles.
These, what we call dipole features twirling around. We don't know really what they are, but the whole feature itself is only 1,000 or 2 kilometers across. It's not very big, but it has like a figure-8 type of look to it.
Believed to be created by winds that roar around the equator at speeds up to 230 miles per hour, these hurricanes can split into 3 and even 4. And the wild weather doesn't end there, because the hottest planet in the solar system even has snow, but not as we know it.
All of a sudden in the radar images, all the mountains go white. Now that's because there's some kind of highly reflective coating. It wouldn't look white to your eyes if you could actually land on the surface of Venus. It might look shiny because we actually think it might be some sort of metallic coating, almost like a pyrite or a fool's gold. So something sparkly, which to me is even better than looking at snow.
These are just some of the puzzles that the European Space Agency's Venus Express, now in orbit, is hoping to solve. As we begin to understand how carbon dioxide controls our climate, there's never been a better time to learn lessons from our neighbor.
What we're trying to solve now, with this very, very dense atmosphere, very complex weather patterns, with the new data from Venus Express, we're really learning by mapping out in 3 dimensions how the atmosphere behaves.
Unprotected by a magnetic shield, Venus is still being robbed of precious water. Venus Express has seen how the solar wind eats away at the atmosphere.
We can see that even today.